So this is a decider combinator. And a decider combinator has two parts. It has an input side and it has an output side. And the best way to think about this is as sort of like a visual representation of an if-then statement. So the input is the if and the then is the output. And you see here that it actually has arrows showing you which side is the input and which side is the output. And that's important to note because you're going to connect those with wires. So here I'm setting up a little example just to show you. I'm going to be bringing in some wood into this requester chest. And I would like to use this decider combinator to set a rule on how it's moved by that inserter. You know that the default behavior of inserters is just to automatically move whatever's in the chest, the source chest, to the thing they're pointing to, and that's what it's doing here. But let's say I don't want it to do that, but I don't want to have to flip it to the side like that to get it to stop. I want to program it to stop automatically at a certain point. So I'll use a condition to do that with a decider combinator. So let's set this up. So let's set it up with these wires here. I'm going to take a green wire and connect it to the input side and to that requester chest, which means that if I open up the decider again, I can now see that that number of wood that's in there, 100, is appearing as an input. So I can use that information now to create a rule that's going to be output, or a condition that's going to be output. So I'll find my wood here and I'll say if the quantity of wood is greater than or equal to 50, let's say. So I want to keep 50 pieces of wood in one chest and 50 pieces of wood in the other. So I'll enter that as a constant. So greater than or equal to 50. If that is true, if that condition evaluates to true, then I need to output something. And that output is going to be what is read by the inserter. So I'm going to get another wire and I'm going to connect the output side of my combinator. I'm going to set this to output a signal, and let's choose W for wood. So that's going to be output, and you can see when the condition is true, then it will output W. And then what I got to do is connect up with another wire, and there's no difference between these wires. It doesn't matter what color you choose. So now my output is pointing to my inserter, and I can enable that when W is equal to 1. Because when W is equal to 1, the quantity of wood is greater than or equal to 50. And so the inserter will now follow that rule. It will only run when the quantity of wood in the blue chest is greater than 50, which means it will leave 50 in the chest. So let's see if it works. So I should have exactly 50 in each side, except I just remembered why I won't, because I forgot to change the stack inserter size, but that's okay. So there's a default setting here for stack size. The default of these ones is 4. But you can change that to 3, 2, or 1 if you prefer. So if you needed to have exact quantities, that's how you would do it. And that's how you use a decider combinator. That's a very simple example. There's much more to it than this, but this will get you started.